Okay, thank you very much. Nice to be here today. Thank you for your time. So today I'm going to talk about some of those converged core issues that we've heard about all this morning. And the good news is I'm going to agree with a lot of the presenters that have already spoken this morning. So I'm not going to spend a lot of time iterating over the reasons of why we need to converge, why this makes sense. At Casa Systems, we bring a little bit of a unique view in that we're a vendor that does radios, small cells, we do core, and we do the CPE that lives on the customer's house. And for the last 3 years, 4 years, we've been working on 5G technology, and we have that end-to-end view. And what I want to talk about today is the disruptor that's coming into the industry, which is fixed wireless, which is the enhanced mobile broadband use case people are talking about for 5G, and in particular, millimetre wave. I'm going to talk about millimetre wave in a couple of slides, but just firstly, just to recap for those of you who aren't too aware, fixed wireless is that use case of being able to deliver a broadband connection to a home or to a user, but that user is in a fixed location. And why is that important? Two reasons. One is it's an equivalent service to a fixed line that goes to a home, be it DOCSIS or DSL or fibre. So it's like a wireless fibre replacement. That's important. Secondly, the nature of that connection, the nature of the CPE or the user equipment that lives on the house is very different to the mobile phones, these devices that you carry around that is your traditional mobility type of devices. And what we're seeing in 5G is that, yes, today people are doing 5G service launches around the world. They are usually on those handsets. And the service that you get from those devices is kind of like a good 4G connection, maybe a little bit faster. Where does it get interesting? When's 5G going to be a genuine fixed line replacement? I put to you that fixed wireless as a use case is that application that's going to make a big difference. So fixed wireless is the ability to throw a signal from a tower or from a lamppost into a home or into a business or into a premise. And the nature of the device, how you design the device, is going to look very different from fixed wireless devices that we see on the market today. Why is that? Let me quickly start by talking about the spectrum asset that you are dealing with here in 5G. Some of this information may not be new to you, but I think it's really important to ground ourselves on the challenges that spectrum present. On the left-hand side is the more traditional spectrum assets that we've been dealing with in 3G and 4G. They are lower frequency, typically from sort of 700 meg up to 2.7 gig. Those low and mid-band frequencies is where 3G and 4G have sat. They're good frequencies, they penetrate well, they propagate well. And they've been used for handset and mobility applications for years and also for industrial IoT or IoT applications. The problem with those frequencies is they're in demand, and the channel bandwidths that are available around the world are relatively small. I've said here 10 to 40 meg. You can get up to 80 meg if you've got the right assets, but they're not big channels. And laws of physics tell us that those sorts of channel bandwidths won't give you huge speeds. I've put on the screen here that you can get 150, maybe 300 megabits per second. That's when you're doing in 4G speak carrier aggregation, or binding together those channels. 5G doesn't change that equation. There's no laws of physics that 5G brings in that fixes that. You're still going to get those sorts of speeds. So when do we have a fibre replacement service? When's that 5G use case coming? Well, the answer is when you have more channels, bandwidth to spend. And that is on the right-hand side of the slide we see here, which is up in the ultra-high band, actually the millimetre wave band. Ultra-high band is this 3.5 gig to 6 gig space. Those channels are in the 100, maybe 100 megahertz, still half a gigabits per second. So when's the fibre replacement coming? Millimetre wave, FR2. But as you can see from my slide, propagation penetration, not really. It doesn't do much. Now, we've been designing small cells and CPU units at Casa to look at this, and the good news is millimetre wave seems to work. Despite all the bad press that millimetre wave has got over the years, it actually does seem to work. Let me talk about some of that bad press. I'm not sure if that's readable for you all. I'll go through them one by one fairly quickly. This is around the perceptions in the press and the perceptions in the market of millimetre wave, and what we at Casa Systems see is actually how this works. So, one of the first perceptions people say is, mobility use cases, these are these handsets, not well suited to millimetre wave. I agree with that, which is why I'm saying fixed wireless as a use case is going to be the starting point for millimetre wave. Right. In-building coverage for millimetre wave is unpredictable. Yes, I agree with that as well. But, and this is the big but, what we're seeing from our experimentation and our end-to-end testing is that millimetre wave finds a way. It isn't predictable, that's true. It's hard to you as a network operator to build and model how is this millimetre wave asset going to propagate and go into these houses. It's hard to model, but it finds a way, it reflects, it bounces, it changes. The problem with that is it changes with external affairs like rain, like weather, like the changing of the seasons, spring, winter. We're seeing very, very different paths the millimetre wave signal is taking depending on whether it's raining or not. So how do you make that work? How does an operator make this high bandwidth millimetre wave asset work in the real world? Well, the answer is you need to put some autonomous intelligence and really smart antenna technology in the UE, in the CPU equipment that lives at the house. That's one of the things that we're working on, and it seems to find a way, as long as it is adaptive and has its own autonomous intelligence to make use of that signal. That's key. Another criticism of millimetre wave is that the cell sizes are small because the propagation isn't very large. That's correct. They're not small. However, what we're seeing, and we're seeing some of the speakers this morning talk about the fact that they're going to see a densified network for 5G. You're going to have lots of small cells, and as long as they're tied with virtualized services to try and reduce the hardware cost down, we believe this is a realisable business case. Obviously, fibre has to be present, or some sort of backhaul has to be present to make that work. Another thing that seems to be in the literature at the moment is, millimetre wave's a long way off. I disagree. We are launching commercial millimetre wave services in 2020. There are some operators around the world who are launching them now. They're early days, and I'd say that 2020 is when millimetre wave is ready for showtime. And so it's coming, and it will work from what we see. People complain that millimetre wave, the beams are not static. I covered this a couple of minutes ago. With reflections, and as long as you have the right intelligence at the endpoint, they're usable. So then the question, so if you've got CPE and small cells that work together and provide a millimetre wave connection, we've now got a wireless fibre connection to the home that should work. How do you then design a network to make use of it? So glad you asked. Here we have a very simplified view of how a mobile network is architected. This is much simpler than what we saw from Simon and from Gerhard in the last two slides. But essentially you have a fixed network and you have a mobile network, and they don't meet. Some operators, and I would suggest the speakers that you're hearing this morning, like Deutsche Telekom and BT, they've got their heads around this. They're working out how to converge their technology into central services. But I have to say, most of the operators I speak to around the world who have a fixed network and a mobile network, most of those operators have two business units or two departments. They have their mobile department, they have their fixed department, and they run their own show because they're different. And my view is if those operators don't change their mode of thinking to bring them into one centralized core, this millimetre wave technology, which offers gigabit speeds, is going to come in and disrupt those operators very, very quickly. So that's the architecture we have today. But what's happening in the market is that all these access technologies that we see coming onto the market, like G-Fast, 5G, DOCSIS 3.1, all these technologies that deliver gigabit services are all demanding these operators come towards a more converged core. So what will that look like? This is a slight variation to what I put up 2 slides ago. This is not as detailed as the 3GPP and the Broadband Forum work that is going on. The problem I have with that work, I don't have a problem with that work, but it's going to take some time before it's all singing and all dancing. 5G is coming, it's launching, and millimetre wave is coming next year. I don't think the industry has time to really wait until all those things settle down. So here is a simplified migration path for operators to be able to put millimetre wave into the field or put those services into the field for 5G. Essentially, it means separating out your handset traffic across the bottom into your traditional mobile core. Those mobile cores tend to be very centralised around the geographic region. whereas the fixed wireless, the fixed network tends to be a little bit more decentralized. It's closer to the points of presence. And so I put to you that fixed wireless traffic could route from the RAN into the fixed wireless core, and in time go into a more converged core, either using BNG, VNBNGs, or other technologies that are coming, and then you have a centralized converged core, which I think has been talked about at length this morning. So I don't really think there's a huge need for me to tell you why that's a good idea. But what we see coming is that once the telco wraps their head around the idea that millimeter wave fixed wireless is another access technology they need to consider as part of their mix, then you're going to need a centralized service that offers the end user experiences in the way that need to be offered. These are things like content distribution network or policy control or parental controls. Those things are all coming in Broadband Forum and 3GPP, but they need to make that step. What does that mean then for what in-home services might look like? If you've made that connection with me so far that this is the way it's going to go, here's an idea. So it could be a VB&G, it could be a centralized converged core, it doesn't really matter. Essentially on the left-hand side, you've got this centralized network that's providing services to the users. And then on the right-hand side, you've got the multiple technologies, the multiple access technologies that are providing services to the user, either be via 5G, via point-to-point, HFC, GPON, cable. Those services can provide an access technology through to the home where you have a modem, and then from that modem, you have a common interface, which I've put here as Ethernet, and then you have your in-home experience. So from the in-home experience, which is these devices here, you've got your home network, Wi-Fi 6, complicated, evolving, and very rapidly evolving. So that right-hand side is changing every 18 months. There's new standards coming out. You can deploy, as an operator, you can deploy this access technology here at the demarcation point of an Ethernet, and then have an evolving in-home network that is separated from the access technology. That's not how the industry does it today. The industry today tends to do integrated devices all through here, saves a little bit of cost, but the way these access technologies are going is they're all tending to go to a multi-gigabit per second speed. You need to decouple your access modem from your in-home experience and have that as a centralized service. So over here, in the cloud side of things, you have all the services that manage your in-home network, and they're abstracted from the access medium that is driving that connection through to the home. As an operator, if you can make that leap and pull yourself away from the access technology, then you can ready yourself for what I think is the big disruptor coming in the industry, which is millimeter wave access to the home. Because it is coming, and it does work. So this has been talked about at length this morning. I think I probably won't go into it much longer this morning. Virtualization, disaggregation of the network is coming. It's happening. You need to disaggregate away from the chassis-based vendor-specific hardware that's currently in place, which is in place per access technology, and move over to a off-the-shelf type solution that provides a platform for scale and efficiency. You need to converge and virtualize your services into a more customer-centric approach. So you're thinking of the in-home experience and a consistent in-home experience detached from the access technology that you've got in place, and virtualize those services into a more lighter weight and scalable solution. Separate your control and data plane, that's a given, and allow as much services to be as close as possible to these many, many G-node beads that are coming with 5G, particularly in millimeter wave. That's a challenge, but it's the way the industry is going. So just lastly, at Casa Systems, this is what we have been readying ourselves for the last 5 years. We have just this year, my previous company, Netcom Wireless, we were purchased by Casa Systems. We were looking after that in-home experience and the 5G millimeter wave endpoints. We've been bought by Casa. We're now part of the Casa Systems family. So now Casa has gone from being a core operator and a cable operator to now having an end-to-end solution, which goes from the in-home experience, the millimeter wave connection, the autonomous active antenna technology, which is connecting you to the network, through to the multi-access solutions that are available, and then through to the converged multi-service core. And that's what we're positioning our company for, to take advantage of the change that is coming and disrupting through the industry. Okay, well, I really appreciate the time. Thank you for your attention. And if you've got any questions, please come and have a look at us at the booth or at the front, near the front door. Thank you.